Hi, I'm back with exercise 11 activity 4. So for this we have the position matrix of n atoms. So let's say xyz coordinates of all of them, and that would be represented in an n by 3 matrix, and we want to find the distance between any two atoms from there. So here we are. Let's say we have the position matrix of atoms 1, 2, 3 up to n and all their x, y and z coordinates. So we have this n by 3 matrix, and then we can find the distance between, say, atom 1 and atom 3 and have this big n by n matrix where we have, say, atoms 1, 2, 3 up to n as rows, and also 1, 2, 3 up to n as columns. So there's this n by n matrix, and the distance between atom 1 and atom 3, we can store that as, say, row 1 and column 3, so here. But if you think about it, the element corresponding to row 3 and column 1, that's going to be the same element. So we see that this is going to be a symmetric matrix where all the ij elements are same as the ji elements, and also the diagonal elements of this matrix, they are going to be meaningless because they represent the distance between the same atoms. So we can ignore the diagonal elements, and also we can forget about the half of the matrix. Let's say the lower half of the matrix we are not going to be interested with. So all the useful information that we are looking for are contained in the upper half of this n by n matrix, and even there we have a lot of zeros because we are supposed to report an element only if it is lower than a certain cutoff. So let's say we have many zeros here as well. So we are in a situation where we have an n by n matrix where a lot of them are zeros, and in a situation like that, a sparse matrix is going to be really useful, because in that case we are going to store only the non-zero elements and the value of the element, and that way we are going to save a lot on time while we are recalling them, and also on memory. And it's especially useful when we are dealing with really large matrices where a lot of elements are zero. So let's see how we are going to implement this.